Hello, my name is Anton, and today I will explain how I did the fourth course project at, uh, at subject computer system structure, computer system architecture. There is a problem with topic, but I will change it later. So this project is about 7-segment display that looks like this. Yeah, somewhere here. Yeah. This is our 7-segment in the circuitry that I gonna use to create this project. At the very beginning, the first step was to get the minterms and characters to display from our file from the left, from this table. My number was 9 and I get these combinations of minterms and characters. Firstly, I structure them and show what my program should do at the very end. Next was to create this table. I decided to use access at those minterms that in this case is a specific combinations of uh, input input bits. Yeah, so those combinations are equal to access, and that means that we don't care about them. I did it because it could potentially make a final Boolean expression more simple when we use Carnot maps for simplifying them, and this and to fill up another one, I use this figure 2 to understand what segments should turn off at specific places, and by using what I did previously, I created this table. So for example, let's take 2. This should display 4 at the very end. So the segment that should turn on at 2 minterm is top left, middle, top right, and bottom right. And as you can see, there is top left, top right, middle, bottom right, and all others are 0. And I did it 6 more times to fill up this. The next step was to derive canonical SOP form. Canonical SOP form, SOP is sum of product, and as you can see, this is literally products, and the result is of every function. In this case, is every segment. This is sum of these products. What are these products represent? You can this is you can find it at the table. So in the table, you choose a specific column that you wanted to make SOP form. Then you look through it and find all ones. In this case, this is this one, and this one. It's 6, 12, and 15. So 6 at binary is 0, 1, 1, 0, and at the right, at the final result, 0 represents negation, so not gate, and the last and the first is negated, and between them these input bit are bits are positive. And I did it 3 more times here and then 7 more times in total. Um, in my file there will be more specific explanation of that. You can see it later. Next step was simplifying Boolean expression. So as I mentioned before, I use Carnot maps for that because Queen McCloskey for me was very too big, too slow, and these Carnot maps also can include the excess don't care ones that I can use to simplify even more final Boolean expressions. Yeah, so how I did it. Um, there will be a little demonstration. So firstly, we need to create that kind of map. AB AB represent the very first column of 00011101 or 10. Let's start with explanation why there is 0, 1, 3, and only then 2. Um, in Carnot maps, you need to have only one change between every row, every column in that bit combination. That's why we cannot put after 1 2, because it will be two changes into binary combination, bits combination. That's why we after 1 we put 3, and the and the same is with CD inputs. Um, CD inputs represented by very first row. How to fill up this map? You go to the truth table and choose again column. For this demonstration, I decided to use first column t function. So 0 in this case 0000 will be the very first square here, and the value that it represents is here, and it is x. So we put here x, and we repeat it um, uh, 15 more times. So 2 representing binary is here, and there we should put 0. 3 we don't use, so there will be x. Then 4 will be again 0. 5 we don't use. 6 will be 1. 7 will be 0. 8 is here and we don't use it. 9 again don't use. 10 is 0, so let's put there a 0. 11 we don't use. 12 is 1, and final 15 is 1. Now we have let's choose color red. Three ones at this function, and we have to follow some rules that this method has to make the most efficient binary sequence, not sequence, but how we call it, binary Boolean expression. Yeah. Yeah. So first rule was to we need to create groups that contains only ones, or as in my case, x's also could be included at this group. So we need to have at this group you can form them like this through borders of this map, and the numbers of elements at this group can be the power of two numbers. So what does it mean? It means that you can form one group of one element, group of two elements, group of four elements, group of eight elements, but you cannot form group of three, for example, or group of five elements. And yeah, so this could um, eliminate most of the variant how to form these groups, and also at this group you cannot forget zero. So how I also you need to form the biggest group as possible as you can. So with this one you can form the biggest group only with this x, because why so unclear? Oh my god, just a moment. Okay, uh, with this group, because around it in this case you have a lot of zeros that eliminates most of the variants how to form a group. And the two ones left are at the same row, so you can form this huge group of four. Once you get your groups, you can check. You should check if it's the most efficient way to form them. You have the least amount of groups. You have the biggest possible groups, and if you check it, you can see that this variant is the correct one. And now we write our result of simplification. So t equal, in this case, so let's start with red one. How we write the result? We look at those bits that are constant at this group. So at this group, at the red group, you can see that first here and first here are not the same, so it's changing. That's why we cannot write a at this case. But all others, like like one here and 1 0 here, we should they are constant, and we must write it into our final simplified formula. Um, so it should looks like yeah, so b is just a b because there is one. Then will be c also without negation, and after that d with negation sign, because the constant that is not changing is 0. Then let's do the same with blue group. Um, so in this case, C and D are changing, are not constant. That's why we need to write only this, and the final result should be AB. And that's how you can simplify. You can simplify very easily your Boolean expression with if you have truth of table, and yeah, that's very simple for me, and it's much simpler than McCloskey method. And yeah, so I did it here at my planchette six more times, and it's very barely seen, but I form all the most efficient group here. Probably later you could check it, but now I believe that's true. So the last two steps are gonna work with um, Circuitverse platform. First step was to create Verilog module and then make circuit implementation of that module to create our final result that later I will show that it works. So the I have one problem with that. So once you can export this project as a file, and once you import it here back, you drag this file here, and there is one mistake, one error. So if you go back, if you go into this second window, you get this kind of code that I write that create a module that transform four inputs into output that should then you should enter into 7-segment display. Yeah, how I did it. So firstly I declare our module. Name of this module is last project. There is 4 inputs, A, B, C, D. You can see it also here. And then all others are outputs. Top right, top left, middle, bottom left, bottom right, bottom. Then you have to assign all of them by using the simplest formula to do it the most efficient in the most efficient way. That's why we find those formulas. Then once you write it down, as you can see, there is a little bit different symbols. Syntax is a little bit different, but the logic is the same, and you just write this formula and you will get the correct result. So this sign is OR, this sign is NOT gate, and this sign is AND gate or multiplication. This is plus, this is you can see minus. To solve problem that it doesn't work, you need to save code. Click at this button. Click at this button. Yeah, Verilog circuit saves saves, and then you the last step you need is just drag from this module into those input into 7-segment. As you can see, you doesn't require to understand what type of inputs, no, where you need to put them. You just drag it to the left until you meet the point, and yeah, it should work. Now let's test it out. Let's test it. So the very first symbol that I needed to display was set 2, and it should show us 4, and as you can see it work. Then it will be 4, it form R, then 6 it form 3, then 7 is B, then 10 is N, then 12 is 2, and the last 15 is 0. So my module is working correctly, but unfortunately Circuitverse cannot save it properly to work without this saving and dragging. And the one downside that I found is that if you doesn't input the correct minterm, the correct combination of inputs, then you get a random result that and that is because of the access that I used into simplified during simplification of Boolean expression. So I think that's all that I did. I think that's it for now. Thank you for your attention. Goodbye.